Hi everybody. Today my topic is continuous compounding. We know regular compounding and it is calculated over specific time intervals such as quarterly, monthly, daily and every hour. But sometimes a bank, in order to attract more business, may offer to not just compound interest every quarter or every month or every day or even every hour, but constantly. And it is continuous compounding. This continuous compounding, it is an extreme case of this type of compounding since it calculates interest over an infinite number of periods rather than assuming a specific number of periods like this. Another important point, it is continuously compounded interest means that an account balance is constantly earning interest. Very important point. It is constantly earning interest as well as refeeding that interest back into the balance so that it also earns interest. If we notice here that M becomes larger, the compound amount also become larger. Look this one and this one. M becomes larger, compound amounts also become larger, but by a smaller amount. In this example, we can see here it is 360. This is 8,640. Big difference in the value of M. But look at these two figure compound amount. It is only 38 cent difference. Only 38 cent. These two. That is why in calculus it was shown in details about that if n becomes infinitely large, then this value gets closer and closer to this. And here E is very important, irrational number, and its value is 2.718281. And this E, it plays an important role in calculus, same as what pi does in geometry. So let's move ahead to see how we can use this formula to find the continuous compound amounts. Again, if we look at here, I have shown using this formula how we get this. So we'll see using this what is the value comes. It will be very closer to this. Let's see in the next slide. Suppose the 5,000 is deposited at 4% compounded continuously. Find the compound amount after 17.5 years. So we know this formula now. Using the value for P 5,000, R we know 4%, 0.04, and years T value 17.5, very easily with calculator we find this value $10,068.76. Interesting thing is, if we look at here, look at by using regular compounding formula, for every hour we got same value, only 1 cent difference. That is why it was said that once m becomes larger and larger, the compound amount also become larger, but by a smaller amount. And n become infinitely larger means this regular compounding results will be very close to z equal to p e to the power rt. Now it's very clear to us. Here all are same, only the things instead finding z, I want to calculate for the t. So we have the value for z as well as we have the value for p. So 10,000, 5,000, 0.04, putting all the values, we get this form, taking log on both sides. So power, this power of log, we have to bring it back, and in back of this. So we can bring this log here. Dividing these two using calculator, we can find very easily t equal to 17.33 years. It's very easy to solve by calculator because formula is not that easy. It's a very simple formula. Now one important things we want to talk about, it is effective rate. Because we know annual interest rate, it is R. But what is effective rate? Effective rate for interest compounded continuously at a rate R, I mean annual interest rate R, then effective RE, it will be e to the power R minus 1. This is the formula. So let's see here how to get that. It is just the amount of interest that $1 would earn in 1 year. Very clear in this line. It is just the amount of interest that $1 would earn in 1 year. So assume P equal to 1, T equal to 1 and R equal to 0.04. Then we can use this formula P1 e to the power R value 0.04, T also 1. So we get compounding value, continuous compounding value is e to the power 0.04. Our P was this. So this minus this, we will get the amount of interest earned in 1 year, e to the power 0.04 minus 1. Using calculator, we can find it is 0.0408. So our effective rate will be 4.08%. But our annual interest rate was 4%. So this value is somewhat larger than 4. That's all for today. Thanks for watching.